This is part 2 of 3 of the video series entitled Angular Quantities for Rotational Kinematics. Now in this video we're going to talk about angular velocity. Angular velocity symbolized with the Greek letter omega, which looks like a W but it has its the top curved inwards. Now angular velocity, like any velocity, velocity is the change in displacement per unit time. So when we talk about omega, omega is going to be equal to the rotational displacement, theta, divided by the time it takes. So we're talking about how this angle here changes per unit time. The units for omega will be radians per second. Now, velocity can also be measured in revolutions per second. I should note that it's angular velocity measured in revolutions per second or revolutions per minute. You may know that as RPMs. And 1 revolution per second, that means 1 complete circle around, 1 revolution in 1 second is equal to 2 pi radians per second. So 2 times 3.14 radians per second. Now, what I want you to notice is that depending where you're on this rotating disk or rotating surface, your linear speed may be higher or lower than an adjacent position along that radius. So just look at this pen right here. So let's say that this represents the center of the circle and you have 2 runners on a track. And this one is closer to the center and this one's on the farther outskirts. And you can recognize that if they are moving neck and neck, the person on the outside is traveling a greater distance and therefore is going to have to run at a faster linear speed. But its angular velocity is identical because you're going, let's say it takes 1 second to go from this position to 90 degrees. That would be 90 degrees per second, or 1/4 revolution per second, and we can convert that to radians per second. So note, the greater the radius, the greater the linear velocity v, but omega is the same for objects moving neck and neck at different radii. Now we can relate angular velocity to linear velocity. Linear velocity is also known as tangential velocity because the velocity is tangent to the radius. So we use this formula right here. V is equal to r omega. I slipped in a t there just to emphasize that it's tangential. And you use that to convert between linear and angular velocities.